Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is Combination Sum Part 2. Okay, so you will be given a collection of candidate numbers, okay, candidates, and a target number will be given to you, and you have to find out all the unique combinations in the candidates where the candidates numbers sum up to the target. Okay, so each number in this particular candidates array may only be used only once in the combination. Okay, and the solution must not contain duplicate combination. Okay, so duplicate combinations are not allowed in the solution. So let's try to understand what does this statement duplicate combinations not allowed mean. So if you take this as your example, put okay, let's open the board and let's paste this example here. Okay, let's zoom in a little bit. I think now it should be full enough. So what we will be doing is uh, the target is 8. Okay, so one way of forming 8 is taking 1 and 7. Let's say I took this one and this 7. Okay, and then this is one way of doing it, and the other way of doing it is I took this one, the one with red marker, and then this 7. Okay, so again you can see that two different ones from two different positions, but the combination is still the same. Okay, you are using the same numbers, so in combination the ordering really does not matter. So even if it would have been 7 1, then also it would have been counted what's the same combination. Okay, so now what we will be doing here is, so in order to avoid these kind of scenarios, we must somehow find a way to exclude taking the same number in the combination. Okay, so the order really does not matter, and so we must exclude this one next time, or when we are forming the combination. Okay, so let's see how we can achieve that. So in order to achieve that, what we will be doing is, firstly it should be clear to you uh, that you have to find out all the combinations that can lead up to this sum. Okay, so you should not exclude any combination, and before thinking of an approach, it is advisable to have a look at the constraints, because that helps in determining the kind of approach, the method that you will be using to solve your problem statement. Okay, so here the length of the candidates array that will be given to you is of order 100, and candidates are ranging from 1 to 50. Okay, and each value, target value is ranging from 1 to 30. Okay, so of order 30, and these are the constraints. So let's think of an approach. So what we will be doing here is, let's take a new slide, or let's discuss it here itself. So for each index, you will try to make you will be having two choices, either to take it in the current combination, or exclude it from the current combination. Okay, so these kind of choices will be there, and to find the all the combinations and explore these choices, you will be using backtracking Okay, so what backtracking is, for example, let's say you set on to form a target of 8. Okay, and you visited 1, and you are already having 1 in your combination. You are trying to find out the next number that should be suitable in order to achieve the target of 8. Okay, so you require 7, uh, 7 more elements that sum up to 7. Okay, so you came to this 7 and then you added this. Okay, so you immediately achieved the target, and this resulted into one combination. Okay, but what about other options that you might be having? What about this 6 that you could have take, that you could have took? Okay, so for that, what you will be doing is, in backtracking, essentially it's like you are visiting step by step. Okay, and at a certain step, if you are not able to form an answer, or let's say you achieved the answer, then you will come back. Okay, and it's like you are tracing your steps back. Okay, one step back, and then try to see other options from here. Okay, so this is what backtracking is. I hope you are familiar with it. If you are not familiar with backtracking, I will be providing a link of an article explaining what backtracking is and how and when to apply it. Okay, you should be definitely exploring that article regarding backtracking. Okay, now I think you must be having knowledge of backtracking and how and when to apply it. So in order to explore all possible combinations, we will be using backtracking here, and we must also keep in mind that we should somehow avoid the duplicates. Okay, so let's keep backtracking aside for a little bit time, and try to understand how we can avoid the duplicates. Okay, so let's erase everything we have written here. Okay, so let's discuss how we can uh, you know avoid the duplicates. So if we sort the given array, it will be 1 1, and then 2, then 5, then 6, then 7, then 10. Okay, so the sorted form of this array will be this. Okay, so why I have sorted the array is, if you are trying to form a combination. Okay, let's say 1 is already there in the combination, and you are trying to fill this place. Okay, so fill this place in the combination, fill this place in the combination. Okay, and let's say even this one was not there. Okay, you are trying to fill the very first place in the combination, so you decided to put 1 here. Okay, so you just put 1 here, and then you went to the next one. Okay, so you see that again you are considering for the same place. Okay, so you are considering a different option for the same place, and it is the same value. Okay, but if you keep putting on 1 in the same place, irrespective of the fact whether it was a 1 from a different index, if you are putting same thing in the same place, that will result into duplicates. Okay, so the observation here is, if you are putting, or let me clear this, if you are putting or placing same value at the same place in the current, in the combination or current combination, it does not really matter, in the combination. Okay, or let's say the current combination, then it will result into duplicates. Okay, irrespective of the uh, index of that value. it will result into duplicate combinations. So in order to avoid duplicates, what we will be doing is, whenever at a certain place, let's say I am trying to fill this place, okay, whenever I am considering the options for filling this place, I will consider only unique values. Okay, if say let's say I am at 1 and it was equal to its previous value, then I will discard this one. Okay, because if you are trying to fill 1 again at the same place, then it will result into duplicate combinations. I hope it's clear to you. And now let's combine these two things together, taking care of duplicates and using backtracking. Okay, and see how we have implemented our approach here. Okay, so let's bring the code to the board. So this is the code. So let's discuss what's happening inside the code. Okay, and let's move it to a little bit towards left. I think this should be enough. So let's start. So what we will be doing is, we will be first of all forming a current combination list that will be representing the current combination being formed. Okay, then as we discussed, that we have to sort the array in order to avoid duplicates. Okay, in order to avoid duplicates. And the candidates will the candidates array will be passed to a function find combinations, which will be populating this particular array, the combinations that will lead to the target sum. Okay, so then you will be, once this array is populated by this function find combinations or method, then you will be returning this. Okay, and the whole logic of the approach lies in this particular method. So what's happening inside it is, if your current sum, okay, this is a variable that is representing a current sum, initially it was set to 0. Okay, and you started at the 0th index, trying to form the combinations. Okay, so if the current sum is equal to the target, then you will say that, okay, whatever is inside this current combination will count to a new combination, and we will add that combination to the combs array, which is the combinations array. Okay, and we will make a copy of it. Okay, we are making copy of it because we will be modifying this current combination in backtracking. So in order to avoid any errors, we are taking a copy of it. Okay, so then start index is the index from which we are trying to make our combination. Okay, so you will be starting, initially the start index is the 0th index. Okay, you will be starting from the start index and going till the very end of the array. Okay, then you will check whether adding the following, the current candidate to the sum will result into a number greater than target or not. So certain checks are to be performed. The first check is that current sum plus the candidate is the number in the candidates array that is currently being visited or checked for, to be whether it's a good fit for the combination or not. Okay, so this condition should holds true, because if your sum is exceeding the target after addition of the current candidate, then it's not a suitable candidate to be added to the current combination. Okay, so provided it is true, then you will check for the second condition. Okay, so the second condition is, as we talked about, we will be wanting to remove duplicates. In order to do so, when we are trying to fill the same place in the combination, then we will exclude those numbers which are equal to their previous numbers. Okay, So this is what we are doing here. If previous candidate is not equal to the current candidate, okay, so there are no similarities between the previous one, or it might be a case that our index is the starting index, okay, so whatever is present before it really does not matter. If any of these condition holds true, then we are good to go, and we will add the current candidate in the uh, current combination that we are trying to form. Let's say the current combination was xy, and then you added a value z, okay. So you will go further down the line with the help of recursion to explore other candidates, okay. Once you are returning or coming back from the recursion stack, then you will be popping the last element every time, and from here you will be trying to see other possible options that you might be having, okay. So this is what we are backtracking our current combination, okay. So the other possible options will be the other indices while we are doing this traversal, okay. So that is covered, and this is what we will do, okay. And at last you will be having all the combinations in your combinations array, and you will also avoid duplicates, okay. And since we were having two choices for each of the elements, either to take it in the current combination or not, and let's have a discussion about the complexities. So the worst case time complexities theoretically would have been 2 raised to power n, okay, where n is the size of the combination candidates array, okay, order of 2 raised to power n, because for each candidate you are having two options, either to take it in the current combination or exclude it, okay. So 2 into 2 into 2, and it will be n times, so that's why this time complexity. But the constraints of the entries in the candidates and the target value are less, okay. uh, so it will not happen that your time complexity will shoot up to this uh, exponential time complexity, and it will be still manageable, okay. And if you ask me what it will be, so you can say that it will be 2 raised to power k, so, or you can say 2 raised to power length depth of max depth of recursion stack, okay, or depth of recursion stack or tree, whatever you may want to call it, okay. So the size of recursion stack will be appropriate term, I think, okay. So that much you will be order of this, okay, will be the time complexity. And if you want, you can take another factor into consideration, which is the number of, or the average length of combinations, okay, or you can say valid ones, okay. But it's still exponential, but it will not be that high due to certain things, because of the value of the target being limited to 30, okay. And we are also pruning the unnecessary branches, okay, by these conditions. Pruning is like cutting things out, okay. So if a tree kind of structure is like going towards this side, we are pruning this branch, okay. It's of no use, because we are checking with a condition, and if the condition does not hold true for this branch, we will not explore this one, okay. So due to pruning and the size constraints of the entries in the candidates array and the target value, it will not reach that high. By that high I mean that n was of order 100, so it would have been to order 100. But since duplicates are not allowed, pruning is happening, and the values of candidates entries and the targets are very less, so it will not reach that high, and you will stay within the range of 10 raised to power 8 operations. Okay, so this is the time complexity. And other than that, uh, we are using extra space. If you are ignoring the space being used for the combinations, making the combinations, then we are just using recursion call stack. Okay, space complexity is using recursion call stack. So whatever is the depth of the recursion call stack, that will be your uh, space complexity. Okay, so I hope you are clear with the approach, and how backtracking is applied here, and how to solve this kind of problems. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills. And until next time, keep solving more and more problems, and I will see you in the next video. Thank you for watching.